GCSE. So the SOHCAHTOA only apply to right angle triangles. Okay, so SOHCAHTOA is only when the angle has a right angle, when the triangle has a right angle. So these are any triangle. Okay, now obviously these would also work for right angle triangles, but for right angle triangles go with SOHCAHTOA or if you can. Alright, so labelling the triangle. I don't want you to stress and strain about labelling them A, B, and C. You will be given the formulae on your formula sheets, but I just want you to recognise the connection between them. So if I chose to label this angle A, then this length here opposite it would be baby A. Do we remember this? Mm-hmm. If I labelled this big B, then this would be side length B. And then if this is angle C, this is side length C. Okay? So that's how the sides and the angles are connected to each other. That's what I want you to focus on, not labelling them A's, B's, and C's. Alright, so the sine rule. The sine rule is that A over sine A is equal to B over sine B, which is also equal to C over sine C. So A over sine A is equal to B over sine B, which is equal to C over sine C. Now obviously when we do any kind of calculation, we're only going to be interested in like one of the equal signs. So we're focusing on that this is equal to this, or that this is equal to this, or that this is equal to this. Okay, you're not going to have all three of them. You only have one equal sign. For the sine rule, your question will always involve two sides and two angles. Okay, so the question's going to involve two sides, two angles. Now, of those two sides, two angles, one of those things you're going to be trying to calculate. Okay, so you're going to be given one side and two angles, or two angles on one side, and asked to find the other side or angle. Okay, so the sine rule you're going to use when it's two sides, two angles. Let's look at example.
So two sides, two angles, including all the
Yes. That's why I've said involved, because some people are like, well, I haven't been given all of those things. Okay, so as I said, I don't want you to start stressing about labelling stuff, so I just want you to remember the connection. So if I was trying to find this side length, I start with my unknown. I'm going to divide that by what? Sine 32. Careful, sine 32, yeah? And I'm going to say that's equal to what? Or secretly 108. Yeah. Okay, so we write our statements. We're then going to rearrange it so that we can find x. How do we find x? We're going to do good. So the sine 32 is going to be multiplied by the other side, so we can just stick it all in. Like this. These are all degrees, so make sure the caps are in degrees. Oh, yes. Okay, so 10.0 centimeters. Next one, we need to find that angle.
I think this one.
Oh, so this one.
Yeah, because it thinks find the side y.
This one?
Yeah.
Okay, so start writing my statement. So I'm trying to find this side length, if I write y over what? Oh, okay, so we've got a problem. The angle's not there. So we know that we need this angle. Can we find that angle there?
180. Yes.
Nice. Okay, so make sure that you're having a look at the information you'll be given. Don't panic and don't just use a random number just because it's not there. Just don't use 46 because, oh, it's near to the one I want, but not quite. Okay, have a think about it and check it. What is it?
108.
So we can calculate that as being 108. So we're going to have y over sine 108 is equal to
14 over 5,
SBMs. Oh, and we can chuck that in. Alright, so 30.4. Have I got another question, Daniel? Yeah. Alright, so those questions, those examples were finding side lengths. If you recall, you can just invert the sine rule. Okay, so you only need to be given one version of it. You then just flip it the other way up. So if you're trying to find an angle, I would suggest start with the thing that you're trying to find on the top. Because as I said the other day, when it comes to rearranging, sometimes people are not quite sure with it, and then it starts to go a little bit wrong. If you're trying to calculate an angle, you will be using the inverse sine button at some point. Okay? Because you will end up with a statement that sine of your missing angle is equal to some kind of number or some kind of expression. You're then going to use sine to the minus 1 to actually calculate it. Okay? So, we're trying to find the angle theta. So we would start with sine theta over what? Nice. It's equal to what? Okay. Don't forget that your sines all go on the same level and your lengths will go on the same level. So rearranging this maybe, we've got sine theta equals sine 110 over 11 multiplied by 8.7, yeah? Don't stick that in the calculator and then round it. Remember, if you round too soon, then it goes horribly wrong. You can just stick that calculation in if you wish, and then you can do inverse sine and use that A and S key. Yeah, you know that it stores the answer. Alright, so we got 48.0. Alright, so I gotta get it away. So if we want to write our statement here, we would write sine theta over unknown. Okay? So we've got a problem here, we can't use our sine rule to calculate this angle here. However, we can use the sine rule to calculate this angle here. Yes? So I'm going to call that big A, you can call it anything you wish. So I'm going to have it now a new statement. So I'm going to have sine A over 125, yeah, is equal to sine A is too good. Over, yeah. So rearranging that, enables you to calculate A. But do be careful, they do want you to give the answer for theta. So having calculated A, you're then going to have to do the 180, subtract those two numbers again. Okay, so it's kind of similar to that one just now we did with the finding length, but it's obviously you have to find a different angle and then do the 180 degree thing. Okay, so we just do that final step where it's maybe